everybody. We're in Chapter 7, Section 3, dealing with square root functions and inequalities. We're going to start with the parent function for all square root functions, which is y equals the square root of x. And we're going to make that graph right here on this paper. But we're only going to plug in perfect squares for x. So right here, not for x. We're going to plug in a 0 right here for x. And what is the square root of 0? 0. We're going to plug in a 1 for x. What's the square root of 1? 1. Then I'm going to jump all the way up to a 4. What is the square root of 4? 2. Yeah, the square root of 4 is 2. Then I'm going to jump from a 4 all the way to a 9. And what is the square root of 9 if I plug in 3? Then I'm going to jump all the way up to a 16. What's the square root of 16? 4. And the last one I'm going to do is I'm going to do a 25 and a 5. If you look at a pattern here, you can kind of see that all of these numbers right here are perfect squares, actually starting with the number 1. Square root of 1 is 1. But right now I'm going to plot all of these points. We're going to start with 0, 0. Then we're going to go 1, 1. We're going to go over 4 and up 2, 5, 6, 7, 8, 9, up 3, 10, 11, 12, 13, 14, 15, 16, and up 4 right there. So right now, if you were to connect these, all right, curve going like this right here is the parent function. Y equals the square root of x. Just do your best you can in your journal. Draw that square root function. Hopefully you understand all we did was plug in our values for x right here. If you're not sure what I did, I'll kind of do the process. We did the square root of 1, which was a 1. We did the square root of 4, which was a 2. We did the square root of 9, which was a 3. And then we did the square root of 16, which was 4. So that's what we plugged in for all of our values for x. And what are all these numbers right here? These are all the numbers that correspond with your y values. Okay? So that's how I got all of these ordered pairs. So let's go to our graphing calculator. All right? Hit y equals. Type in the square root of x. I'm going to turn my grid line on. Okay? There we go. We're going to go second, zoom, go over to my grid line right here. I'm going to turn it on. And then I'm going to hit zoom number 4 and take a look at it. There's our square root function. Now, this one is not as long, not as big of a graph, okay? So notice we only go over 1, 2, 3, 4, 5, 6, just past the 6. But you can at least see what? You can see it starts where? Right here at 0, 0. There's your 1, 1. There's your 4, 2. Okay, that's the last one you can see. All right, you can't see the 9, 9, and 3 on this. But you can check your table. Second graph, you can check your table. And you can see the 1, 1, the 4, 2, and you can see all the way to the 9, 3. You can keep scrolling, and you can see all the other numbers if you wanted to. But what we're going to do is we're going to do a little investigation, all right, using this. So I want you guys right here. This is y equals the square root of x. I want you guys to go down to y2, and I want you to type in this. Second x squared, which is the square root, hit an x, and do minus 3 underneath the radical. And hit graph, and take a look at it. Where do you notice that this graph starts at in red? Where does it start? At 3. Interesting. Why positive? That's a good question. Why positive 3? Check this out. What number would you have to plug in for x for this to equal a 0? Positive 3. So what does this do? This right here, this translates it what? 3. Yeah, 3 units. Right. So x minus 3 translates the graph 3 units to the right. Now let's go back over here, hit y equals, go down to y2. Let's change this to, say, plus a 4. Let's go plus 4. this graph right here? This is y equals the square root of x plus 4. Well, what number would you have to plug in for x to make this equal to a 0? Negative 4. So what did that do? That translated it 4 units to the left. 1, 2, 3, 4. Go down here. Why don't you guys tell me what's going to happen? I'm going to put plus a 7. What do you think is going to happen? Oh, you can't even see it. That's at a 6. I better change that to a plus 6 so you can see it. It went off the screen. X plus 6. There it is. These are the exact, basically same graph, just one of them has been translated 6 units left. So we're going to add one more element. What if, after the plus 6, on the outside of the radical, I did like a minus 2. I'm going to take everything down 2. Check it out. Do you guys see where did it was right here, wasn't it? But now what happened? It's dropped down right here. So what does that tell you about the number at the end? What does that do to the graph? Changes it. It shifts it up or it shifts it down. So this one right here deals with what's called a what? A vertical translation or a vertical shift. So that deals with a vertical translation. What is this right here? What is that negative 6? What happened? That deals with a horizontal translation. So the numbers on the inside of the radical move the graph left to right, and the number right here on the outside of the radical moves it either up or down. Okay? So let's go back to our original graph, right here. Okay? What I'm going to do right now, in orange, I'm going to make my own graph right here for you. Okay? I'm going to write y equals the square root of x minus 7 plus 3. So I'm going to make this graph right here, and you guys can do it with me. All right? So where is this going to start? It's going to start at a positive 7, and the y value is going to be at a 3. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3. So this graph will start right there. Now I'm going to erase some things that you guys don't need anymore. You don't need this. Oh. So I'm going to start there. Now look at the pattern. I went up one end, over one. So I can still do the same pattern there. Then I went up one and over 3. So I can still do the same pattern because nothing else has changed. And then what do I have to do? Go up one and over 1, 2, 3, 4, 5. So up one and over 1, 2, 3, 4, 5. That'll be the last one. So I want you to understand this right here would be my graph that goes with this one. What happened to this? This was translated what? 7 units to the right. 3 units up. So that could be kind of an example you could have in your journal of how to translate a square root function. All right, what I'm going to do is I'm going to zoom in on problem number 2, right here. Zooming in on problem number 2. Now, just looking at this, without even using the graphing calculator, where do you think I'm going to start the graph? Negative 7, negative 4. How did you figure that out? Because what number would you have to plug in there to make this right here equal to a 0? We'd have to plug in a negative 7 to make this right here equal to a 0. So I'm going to go over negative 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4. Why are we going down 4 units? Because of that minus 4 right there. So negative 6 would probably be at a negative 3. Then if I go up 1 and over 5, all right? Up 1 over 3, actually, from right here. You're probably be at what, a negative 3 and a negative 2. If I go up 1 and over 1, 2, 3, 4, following that pattern, that would put me at a what? At a 2 and a negative 1. And we'll put 3, and we'll figure out where 3 is using the graphing calculator. But here's where your graph would look like. Just do your best to sketch it to the points that are actually plottable. Yeah, turn out really nice. Okay? So right there, there's your graph. I'm going to hit y equals so you guys can see it. Clear this out. Go down here, clear this out. So y equals a second x squared. I'm going to type in x plus 7. Don't forget, you have to hit the right arrow to close off that radical. Minus 4. Now check your table and you'll see these points. Where did we start at? We started at a what? Negative 7. And there it is. There's negative 7, 4. There's negative 6, 3. There's negative 3, 2. There's 2 and a negative 1. And it looks like 3 is at a what? Negative 0.8. So I'll just go over here and put negative 0.8, even though I can't plot it. Okay? Now, what we need to talk about in this graph are two things. One of them you see right here. It says domain. And the other one I got to write, because I don't have room here. Got to write the word range. Okay? What is the domain? The domain is the set of all of your x values. So just remember, for domain, I want you guys to write set of x values. And the range is the set of y values. Okay? So right now, what is the first x value that is actually plottable? The very first x value that's plottable, negative 7. So right here, we're right. The set of all x values such that x is greater than or equal to a negative 7. This is set builder notation. Okay? The set of all x values such that x is greater than or equal to a negative 7. I'm just going to follow it with my pen so you know how I'm writing it. Where does the range start at? Where do all the y values start at? Negative 4. Are they getting bigger or smaller than a negative 4? They're getting bigger. So you would say the set of all y values such that y is greater than or equal to a negative 4. So your domain, all of your x values are getting bigger than or equal to a negative 7, and all your y values are getting bigger than or equal to a negative 4. One thing I forgot to talk about is what's the domain and the range of the parent function. Okay? So in your journal, go back to the parent function, which was right here. What would the domain of the parent function, the one that goes right here, what would the domain be for that guy? X such that?
X to be greater than or equal to 0.
That's correct. That's the domain of the parent function. What about the range of the parent function?
Y such that Y greater than or equal to 0.
Very good, because it's going, all the x values are going what? They're going greater than or equal to 0. All the y values are going greater than or equal to 0. That's how you find your domain and your range. Okay? All right, we're going to go to problem number 1 real quick. Show you guys how to find the domain and the range for problem 1 without a whole lot of effort. Right now, I need you guys to set this equal to 0. So right now I'm going to write 3x minus 4 equals 0. You're going to add 4 to both sides. 3x equals 4. Divide both sides by 3. And x equals 4/3, which is approximately equal to 1.3. Technically it's 1.3 repeating, but that's approximately equal to a 1.3. So right here, at a 1.3, that's where the graph starts. Here's your domain and your range. You start at 4/3,